Hey guys, how's it going? My name is Daryl. Welcome back to the channel. In the last lessons, we broke down the full logics and flow of the algo and coded the RSI hidden divergence in Python step by step. Today, we are shifting the focus to the Stochastic Oscillator Crossover, an excellent timing and confirmations tool. I will walk you through the logics behind it, the %K, %D smoothing and threshold setting, and then show you how to implement it in Python line by line. We will also demonstrate how to detect the crossover so you can use them to time the entries and filter out the false signal. Let's get started. Before we jump into the code, let's quickly walk through, let's quickly talk about the stochastic oscillator, which is one of the most popular momentum indicator that basically compares the current closing price against the recent high-low range or against the price range, and giving us two lines. The first one is the %K, the fast line, and then the second one is the %D, that is the slower, smoother line. And there are basically two types of signal. One is the overbought or oversold, and the other one is the crossover signal. And when %K and %D move about 80, the market may be overbought. And then when the %K and %D that is below 20, it may be oversold. So in that case, of course, it just indicates there's a potential downturn or potential upturn. On the other hand, that is another group of the indicating signal, that is the crossover. Bullish crossover happens when %K cross above the %D, that is the potential buy signal. On the other hand, a bearish crossover happens when %K crosses below the %D, that is the potential sell signal. And traders normally use these crossover along with the overbought or the oversold levels to time the entries, exit, and also spot possible reversals. All right, with that in mind, let's see how to code it step by step. First thing first, let's copy all the codes related to the RSI strategies that we've developed in previous lessons. So the first one is basically the main strategy. And then just like what we've done in the previous lessons, we actually create the hidden divergence that we used it to detect the RSI divergence. And then let's initialize the MT5 and initialize the MT5, connects it to the MT5 and retrieve some data points so that we can develop our strategy. All right, let's take a look first and see if we can retrieve the data. Excellent. What we've done is that we simply initialize the MT5 and then retrieve the bitcoins with 250 bars, and then put everything into the data frame, pandas frames. And then what we're going to do here is to use the technical analysis to calculate the %K and %D. What we're going to do is to call out the functions that is from the technical analysis, from the panda analysis, and then pi equals to pi, and then the low equals the low, And then we just take the norm, that is the K equals to 14, and then D equals to 3. So that means that what we're going to do is that for this high equals to high, just tell us which columns in our data frames holds the high price, and then for the low equals to low, just like what I mentioned, similar to the high, we just specify the columns to hold the low price. And then for the K equals to 14, just set the percent K look back periods to 14 bar. And then for the D equals to 3, just means the percent D line is a 3 periods moving average of these percent K. So this should probably result a new data frame. But before we show it, we better just rename it. So for better indications, that is the column. So basically this sorry. Maybe I will show you the name first. So you can see this is the Stochastic that is the K, that is the percent D line. So what I'm going to do is just to rename them. And then the first one, let's rename it to K, and then for D, let's rename it to D, and then in place equals to true, and so here we go. After having these percent K and percent D columns, we can integrate it back to the strategy function, and we just simply copy and play these two lines and put it back to the function. And the next thing is that we need to determine the crossover. And with that in mind, we are going to create a functions that is the stochastic crossover, that we are going to get the data points provided from this stochastic. And then what we're going to do is to create functions that is the stochastic crossover. And then the first thing is to calculate the difference between the percent K and percent D. That is the K minus D minus the data dot K minus the data dot D. And then this is going to create a new column that it's the difference between the K and D. If it's a positive, the percent K is above the percent D, and then if it's negative, the percent K is below the percent D. And then what we're going to do, of course, is we would like to detect the crossover. And then we're going to define a column, and then we are going to use a psi functions, the numpy psi functions, to turn the K minus D values, that is the value in this column here, into either one or into a positive, in a +1 or a -1, A +1, just like what I mentioned, means that the K is above D, and then if that is the -1, and then that means that is the K is below the %D. And what we're going to do is to measure the difference. That is the difference to check the changes from one bar to the next. So that means what we're going to do is to check the current sign, and then to detect the previous sign. If there's a changes, it means there's a crossover happening. And then the final is NE equals to 0, just return to true whenever the sign changes, meaning the crossover just happens. And then what we're going to do is that we are going to draw NA to make sure there's no NA. So that equals to true. So when we drop the NA, it means that we're going to remove this row that we haven't had the %K and %D. And then we also would like to force the first few row as false. This should be the very first row, not the first few rows, sorry. So we force the very first rows as crossover values to false. So we don't accidentally detect a crossover at the very beginning. And so what we've done is just now replace the crossover. Before I go to this line, I just would like to quickly mention what we've done here. If positive in this crossover, it just means there's a fast cross from low to high. And then on the other hand, if it's a negative, it just indicates a fast cross from high to low. Now, instead of just providing the sign, what I would like to do is to return an actual numbers that is the K minus D. So in this crossover column, I would like to replace those true value data, those true value with the actual difference between the K and D. So just replace it, and for those, for the other, there's no sign, there's no indications of crossover. I will just provide an end, and these functions is going to return data, returns the data, and then later on I can update back to our original data frame. So let's see what we've done here. So let's call this function that is still equals to this function, and then this data. This should be this data for the inside, and then we're going to print this one. Oh yes, I should use the so instead of the data. Yep, and there's a typo. The sign should be KD. Here we go. Now it will print out all the %D, %K, and also %D value, and also the difference, and then also the crossover. And then you can see for this crossover that happens, we will store the values, the differences, and then back into the crossover column, and which it will let us understand whether or not there's a bullish or bearish signal. Now to help you better visualize exactly what where these stochastic oscillators crossovers happens, I've actually prepared a plot showing the %K and %D line along with the bullish and bearish crossover points. And I'm not going to go too deep into the plotting code here, but he's basically, so what we're doing is just repeat all these functions and then that we've already built. And then for the chart itself, we will have the blue line, that is the %K, that is the fast stochastic, and then the orange line is the %D, that is the slow smoothed stochastic, and then the green upward arrows, the green upward triangles marks the bullish crossover. That is exactly where's the %K line over here, a course above the %D. And then the wet indications, the wet downward triangle marks the bearish crossover. That is where %K causes below the %D. In this way, we can instantly see on the chart exactly where the potential buying signal and also the selling signals appear. Now that we've built all the pieces, it's time separately, it's time to put everything back all together. And then so we have the stochastic informations here. So just put it here. So we have the main strategy, and then we have the hidden divergence, and then we also have the stochastic crossover. What I would like to do here, because we are using the another data frame, so what I'm going to do is simply to concat this stored data frame back to our main data frame. That is and then row by row, sub-651, and then we are going to re-index according to the main frame. Now let's run it and print the data. Excellent. We just concatenate the stow crossover data back to the main data frame, main data table. In the next episodes, we'll complete the entire strategy by adding two powerful trends filter, that is the EMA 50 and also the EMA 200. And these moving average help us to define the broader market directions, telling us whether or not we are in an upward trend or in a downward trend. This step is the most critical one for improving the trade accuracy by aligning our entries with the overall trends. Make sure you don't miss it. See you in the next episode.